Hello everyone, so in this video we will be discussing about the programming language fundamentals, in which it includes the coding conventions and data types as well as the constants and variables. But now we will be discussing first what is coding standards. So basically, coding standards are just the guidelines for code style and documentation, and the goal is that any developer familiar with the guidelines can work on any code that follow them. And as well as the standards range from a simple series of statements to involved documents. So basically, coding standards are just the standards that we are following whenever we create a program or whenever we create a system. So why do we need to have coding standards? So we need to have a coding standards in order for our software to be easily maintained. And if our software can easily be maintained, there meaning to say there would be less bugs, and whenever there we will be encountering some bugs or problems or errors in our codes, later on we can just easily fix them and we can just easily identify them because we are following standards. And it would be easier for the teamwork and the team switching. So in a company setting, you will not only be the one to work on a program or a system. There will be teams, or there will be different teams that will work on one system. We have the quality assurance teams, we have the developers, and also there would be also developers that has different functions or that is developing different functions in the system. So there will be easier team switching that will happen if your program is under the standards. And for the cost, um, it would have your system or your project will have a minimal cost, especially for the maintenance cost, because you are already following standards and there will be no need for you to hire other developers to check on your program anymore. And your system will have greater consistency between developers, easier to develop and maintain, and saves time and money. So it would be easier for them, it would save time and money because it would be easier for the developer to identify directly or easily the codes that is producing an error, for example. So we have this data flow here, or the program flow. So we'll start with the planning, and it would undergo analysis. And then after the analysis, there will be different designs that will come up. And then after we can settle in the design, there will be implementation. In the implementation, there will be tests that will be conducted. So during the testing, there might be an error, or there will be bugs. So that's why it would go again under maintenance, and then you have to plan again what you have to do with those bugs. And then it is just a cycle. This is just a software cycle. There are three rules in coding standards. We have to find a standard that works for your team. So basically, it does not necessarily mean that this company is using this standard, you should also use this standard. No. You have to find what standards that is suitable for your team or for your company, then that will be the standard that you need to follow. It does not necessarily mean that you have to copy the standards of other, but it would also be good to ask some ideas from them. But it does not necessarily mean that you have to have the same standards with other companies. The second rule is to standardize early. The effort to bring your old work into the standard will be too great otherwise. So before you start the program, or before you start creating the system, you have to identify what would be the standard that you will be using, so that as early as you start the program, though it will be under standard already, and there will be no need for you to rework on your old works in order for those works to be to follow standards. So as early as starting the program, it would be better that you standardize already. And you also have to encourage a culture where standards are followed. So we have two types of coding standards. We have by company and by language. So that basically means that in every company there are different standards that are following, and also it depends on the language that we are using. So if this company X is using this standard, it does not necessarily mean that company Y is also using the same standard. And also there are different standards in different languages that we will be using, like different standard for C++, different standard for Java, different standard for C Sharp and other languages. They has different standards, most probably. There are common practices in coding standards. There are a few common practices that we use in coding standards. And to name a few, these are indentation, commenting code, white space, and naming variable. So let's discuss first each of this. We'll be discussing each of this, but let's discuss first the indentation. Indentation identifies scope in some programming languages for the compiler, indentation of functions, objects, and etc. So this is an example of indentation. If you could compare this code from this, as you can observe, this code is easier to read and easier to understand, and as well as easier to maintain. Unlike this code here, which would have a confusion between one programmer to other programmer. Because as you can see from here, it is very messy and it's not pleasant to look at, and it's very hard to debug this kind of programming standard. And clearly it is also not following standard, because in if you would compare it to this code here, it is easier to understand and it would be easier for us to debug if there would be future errors in this code here. So unlike here, it would be harder for us to know which line or which part is producing an error, because as you can see, it is just in one line. So it would be better to use indentation here. This is an indentation. There is tab space, as you can see from here. We also have the commenting code. So comments should clearly demonstrate the function of the code both to yourself and to other developers. I believe you already know how to use comments in programming. These are just basically the slash, two slash. This is how we do comments in programs, the two backslash, or if you want, there is also asterisk and asterisk here. So this is how we comment codes. And comments should not be too long, and comments should not be every line, exceptions for functional languages, and comments should not be overcomplicated. So comments should only be used to identify, or in order for us to have an identifier that this line or this function, this is for the addition, this is for the subtraction. So comments are just for an identifier for the important codes in your program. So there is no need for you to comment all of the line. Like for example, this line is for output, this line is for input. So there's no need for you to comment all of those, especially if it's not important. We also have the white space. White space is very important but often overlooked. It makes the code easier to read, and especially important with large programs, lack of white space can be very confusing. So this is an example of a code that has a white space, and this is an example of a program that has no white space. So you can see this one here, this is called white space because there are spaces, there are ample of spaces here that would make our program look easier, or it would make our program easier to read and identify. Unlike this one, it would be better to segregate, or to put the curly braces aside from the code that we have. So it would be better to have this code than this one. especially if your codes are already lengthy enough and it would be harder for you to identify already later on. We also have naming variables. Variable names are often thought to be less important, but they are vital to understanding certain pieces of code. In the majority of programming languages, variables can be assigned almost any name. So for example, if you are asking the user to input the value for the age, so it would be better to use the age variable rather than to use the variable x, because later on, again, if you have a very lengthy program later on, it would be harder for you to remember that this x is equivalent to age. So it would be better that as early as starting the program, you have to name your variables as it is used in your program. So if you are asking the user to input the age, then it would be better to just use the variable age rather than the variable x. Because again, this might lead to a confusion. So for example, this one here, it uses variables that are not really helpful in remembering what these variables are for, like AH, Z, 0, or 0 or O, and we also have T and E. So this code can do anything. We don't know what values they are comparing, especially if we just look at this one. If you are not a developer and you are just looking at the code, so we will not know what values are they comparing. Unlike if you would say age 1 is greater than age 2, something like that, or age is greater than number, so it would be easier for us to identify. So that's why it's very important. However, it's also overlooked the importance of naming your variables correctly. So there are quotations from different coding standards here. Example of those are using spaces, not tabs, 3-character indent, 4 is more common, get agreement and enforce with a tool, no long lines, limit the line length to a maximum of 120 characters. No trailing white spaces on any line and put brace on a new line. We also have single space around keywords. So for example, your keyword is if. It would be better to have space in between the parentheses. And single space around binary operators. So if your number is 42, space the operator, space the another number. So these are just other standards that other developers are also using. No space around unary operators. Example, this plus plus here. There should be no space in between the I. No space before parentheses with functions or macros. Example, Fred, and then you have parameters here, the 42 and 69. And single space after parentheses with functions or macros. This one. This here are the single spaces that we have. And layout list with one item per line. This makes it easier to see changes in version control, one declaration per line. Function calls with more than two arguments should have the arguments aligned vertically. Avoid big functions and methods. Avoid deep nesting and always use braces with if statements, meaning to say you have to use curly braces for if statements. And the condition here, you have to put curly braces. And this makes changes shorter and clearer in version control. So these are just few coding standards that other developers are also using. So now we'll be discussing data types. So data types, an item's data type describes the type of data that can be stored there, how much memory the item occupies, and what type of operations can be performed on the data. So we have already discussed the overview of data type and what are those data types that we use. And here we'll just be discussing this more in depth, the data type. So we have these data types here, the organizational chart of our data types. There are two types of data types, which is primitive data type and non-primitive data type. Java uses primitive data type. That means it uses Boolean and numeric. Under numeric, we have two types. We have integer and floating. Under integer, we also have two other types, which is integer and character. Character is still under integer because if you can recall, character can also accept numbers. so long as it's only one letter, one symbol, and one character. So that is the work of our car. And for the integer, we have different types. We have four types of integer, that is byte, short, int, and long. So this data types here accepts input from the user that is an integer or a whole number. However, we also have the floating, which has two kinds. We have the float and the double. Float and double, as we know, works the same. They accept inputs from the user that is a number and has a decimal points. However, the difference between the two is double is more accurate than float because double has a bigger memory than float, and it can also display decimal points until 15 decimal places. However, the float can only show or display 6 to 7 decimal places. So that's why double is more accurate than float. Under the non-primitive data type, we have the class, array, interface, and string. So string here is other data type that we are also using. However, this is under non-primitive. These are the sizes and ranges of the primitive data types. We have the int, long, float, double, and decimal is only for C sharp. We also have the string, the char, and the boolean. So these are the sizes of these data types. The int, we have 4 bytes. This one, the range of this one is from this to negative 214748368, and so on. Boolean is just true or false. Character is one character only, and that's 16 bits. For the string, it's 16 bits per character. So again, string and character are just the same. However, string accepts many letters, many character, and many number. However, character can only accept one letter, one character, or one symbol, and one number.